Okay, so complete the square to rewrite the equation of the following hyperbola. So we did a complete the square problem with the ellipse before. The key to know that it's a hyperbola is the fact that we have a negative in front of our y squared. If we had a negative in front of the x squared, negative in front of either one of these suggests that there's a negative in the middle of the formula, and that's where we know it's a hyperbola instead of an ellipse. I'm not worried about the negative 40x or the negative 24y. It's all about that negative 3 in front of y squared. So let's dig into this just like we did with the ellipse. We're going to start by putting all the x terms together. 4x squared minus 40x, and all the y terms together. Negative 3y squared minus 24y. Then we have the constant all by itself equals 0. So to create my perfect square trinomial, remember, I need just x squared. So I'm going to factor out the 4, and I have 4 times x squared minus 10x. When I deal with the y term, I factor out the negative 3. That means I'm dividing everything by negative 3. So I get the y squared, but negative 24 divided negative 3 gives us the positive 8y. Now, the fundamental part of complete the square is we take half of the variable term. So in this case, I take half of the negative 10, and it gives me negative 5. So I say x minus 5 quantity squared with the 4 in front. I do the same thing over here with the y term. I take half of the 8, so I have y plus 4 quantity squared with the negative 3 in front. Now, the part that I don't put in here, because I'm not trying to make it look longer and harder than it already is if I were to actually write x minus 5 twice and square it out, I would get x squared minus 10x like we have up here, but I would also get plus 25. With the 4 in front, 4 quarters is $1, so 4 times that 25 is 100. So if I'm adding 100 over here, I have to subtract 100 to compensate. The same thing with the y term. If I multiplied this out, right, I would have y squared plus 8y plus 16. And then negative 3 times 16 is negative 48. So by writing this perfect square trinomial, I'm subtracting 48 here. So I'm going to add 48 to compensate. And remember, I still have my constant, negative 92 equals 0, negative 92 equals 0. So now we're almost home. I'm going to bring down this expression with the 4. Now I've got 4x minus 5 quantity squared. I'm going to bring down the negative 3, y plus 4 quantity squared, and I've got the 144. So the question is, where did the 144 come from? So all I did was put all the constants together. So negative 100 and negative 92 is negative 192. When I add the 48, I have negative 144. And so in order to get the constant on the other side, I add 144 to both sides. And that's why I'm dividing everything by 144. So last step, we just simplify the fraction. 4 over 144 is really 1 over 36. So I have x minus 5 squared over 36. Negative 3 over 144 is really negative 1 over 48. So x minus 5 squared over 36 minus y plus 4 squared over 48 equals 1. Because remember, if it's an ellipse or a hyperbola, It has to be equal to 1. And the key is, now that I've solved this, I can go straight to my graphing calculator and actually graph it. So to pull up our template, we do Menu, we do Graph Entry Edit, Equation Templates. We know it's a hyperbola. Since the x comes first, the x is in the first fraction, the negative is over here with the y, we know it looks like this. So this is an east-west hyperbola. Now, since I need this in terms of squares, it's still not bad because all I have to do is put the square root of 48 squared. So I go square root 48, and there it is. That's my hyperbola, right? So I know that I want to be able to see it, so I'm going to zoom. Now, when I analyze my graph, it's a conic, right? So I analyze graph, and way down there for number 8 is analyze. I want to find the center, so I click on the hyperbola, and there's the center of our hyperbola. Now, I want to move this equation out of the way just a little so that I can actually see the asymptotes. So Menu, Analyze Graph, Analyze Conics, Asymptotes. So I just click on the graph, and there are my two asymptotes. And that's how we can use complete the square to find the center and the asymptotes for a